I am the virtual teacher at Egnatia Career College. Today we'll teach fireplaces, stairs, insulation and room finishing, cabinets, lake house specifications. This is video number 7. Fireplaces. After completing this unit, you will be able to perform the following tasks. Describe the foundation, firebox, throat, and chimney of a wood-burning fireplace using information from a set of construction drawings. Explain the finish of the exposed parts of the fireplace, using information from a set of construction drawings. Explain the methods used to vent a gas-burning fireplace. Basic construction and theory of operation of wood-burning fireplaces. A fireplace can be divided into 4 major parts or zones: foundation, firebox, throat area, and chimney. Each of these zones has a definite function. To understand the construction details, it is necessary to know how these zones work. Foundation. The fireplace foundation serves the same purpose as the foundation of the house. It supports the upper parts and spreads the weight over an area of stable earth. The foundation consists of a footing and walls capable of supporting the necessary weight. The fireplace foundation sometimes houses an ash pit. The ash pit is a reservoir to hold ashes that are dropped through an ash dump, a small door in the floor of the fireplace. When the foundation includes an ash pit, a clean-out door is installed near the bottom of the ash pit. Firebox. The firebox is the area where the fire is built. In all wood-burning masonry fireplaces, the firebox is constructed of 2 layers of masonry, as shown in this figure. Each layer is called a width. The floor of the firebox consists of firebricks laid over a concrete base. The concrete base may extend beyond the face of the firebox to support the hearth. The hearth, which may be tile, stone, brick, or slate, forms a non-combustible floor area in front of the fireplace. The outer walls of the firebox are most often common brick. The inner walls are of firebrick to withstand the heat of the fire. The back wall of the firebox slopes in to direct the smoke and gas into the throat area. The masonry over the fireplace opening is supported by a steel lintel. The lintel is long enough so that 4 inches of it can rest on the masonry at each end. Throat. The throat of the fireplace is the area where the firebox narrows into the chimney. Modern wood-burning fireplaces are built with a metal damper in the throat. The damper is a door that can be closed to prevent heat from escaping up the chimney when the fireplace is not in use. The damper is placed on top of the firebox with 1-inch clearance on all 4 sides. This clearance allows the metal damper to expand as it gets hot. The flat area behind the damper, above the sloped back of the firebox, is called the smoke shelf. The smoke shelf is especially important for the proper operation of the fireplace. The cold air coming down the chimney hits the smoke shelf and turns back up with the rising hot gas and smoke from the firebox. This helps carry the smoke and gas up the chimney. If the smoke shelf is not built properly and kept clean, the falling cold air can force the smoke and gas back into the firebox. Chimney. The chimney carries the smoke and hot gas from the throat to above the house. The top of the chimney must be high enough above the roof, trees, and other nearby obstructions to ensure that the air flows evenly across its top. According to the International Residential Code, the chimney must extend at least 2 feet through the roof and 2 feet above anything within 10 feet. However, the dimensions on the drawings should always be followed. To ensure fire safety and a smooth inner surface, masonry chimneys are lined with a clay flue. This flue is installed in 2-foot sections as the chimney is built. A 1-inch airspace is allowed between the flue lining and the chimney masonry. In recent years, insulated, metal chimneys have become quite popular. These chimneys are lightweight, they do not require massive foundation for their support. It also takes less time to install them. Because the outer wall of a metal chimney remains cool, it can be enclosed in wood. The chimney sections are slipped together and fastened with sheet metal screws, then, the chimney is framed with wood and covered with the specified siding and trim. A chimney enclosure of this type is called a chase. Prefabricated metal fireplaces. Constructing masonry fireplaces is time-consuming. Their great weight requires massive foundations. Engineered, metal fireboxes have been developed that can be installed in very little time and require only modest foundations. The prefabricated units are available from several manufacturers and in a variety of styles. However, they are all similar in that they have double walls and a complete throat with the damper in place. Most also have a fire brick floor. The double wall improves the heating ability of the metal fireplace. Cool air enters the space between the walls through openings near the bottom. The air absorbs heat from the fire, and because warm air naturally rises, it exits through openings near the top of the unit. The outside surfaces of the prefabricated unit are cooled by the circulating air. The unit can be enclosed in wood if recommended by the manufacturer. For a more traditional appearance, the exposed face of the fireplace can be covered with masonry veneer. Gas-burning fireplaces. Gas-burning fireplaces are a feature of many new homes and are becoming more common than their wood-burning ancestors. A gas fireplace is an appliance that is installed as a unit. The prefabricated unit is installed in a wood frame enclosure. Because the outer housing does not get as hot as that of a wood-burning fireplace, it can be installed closer to combustible wood framing. The unit is vented to the outside, and the gas line is connected to complete the installation. Any style of architectural trim can be applied to the front of the chase after the unit is installed. Gas fireplaces are efficient, but some heat is lost through the metal surfaces. It is very important that the manufacturer's specifications and instructions be followed to ensure safe venting and to keep combustible materials a safe distance from hot surfaces. Gas-burning fireplaces can be vented straight through the building wall or vertically through a chase. Clearances and framing details are provided in the manufacturer's instructions. Fireplace drawings. Where a gas fireplace is to be installed, most of the information about the fireplace is found in the manufacturer's installation instructions. Gas appliances are fairly lightweight, so there are no special foundation requirements. Wood-burning fireplaces, however, are constructed on site from masonry materials, so the building plans and elevations must supply all the construction information. The foundation is normally included on the foundation plan for the building. The dimensions and notes show the location of the fireplace foundation, its size, and the size and type of material to be used. The floor plan of the house shows where the fireplace is located and its overall dimensions. The building elevations show the chimney. More detailed information about the fireplace is shown on the fireplace details, which usually include a cross-section. The following information is often included on a section view of the fireplace. Dimensions of the firebox. Materials used inside the firebox, firebrick. Materials used for the outside of the firebox and chimney. Ash dump, if any, is included. Lintel over the opening. Dimensions of the hearth. Mantle, if any, is included. Dimension from the smoke shelf to the flue. Size of the flue. Materials for the chimney. An elevation of the fireplace shows the exterior finish of the fireplace. Only those features that could not be adequately described on the section view are called out on the elevation. However, this view shows the exterior finish, the mantle, and the trim better than the section view does. Stairs. After completing this unit, you will be able to perform the following tasks. Identify the parts of stairs. Calculate tread size and riser size. Stair parts. In order to discuss the layout and construction of stairs, you need to know the parts of stairs described below and shown in this figure. Stringers are the main support members. The assembly made up of the stringers and vertical supports is called a stair carriage. Treads are supported by the stringers. The treads are the surfaces one steps on. Risers are the vertical boards between the treads. A landing is a platform in the middle of the stairs. Landings are used in stairs that change directions or in very long flights of stairs. The run of the stairs is the horizontal distance covered by the stairs. The rise of the stairs is the total vertical dimension of the stairs. The nosing is the portion of the tread that projects beyond the riser. The underside of the nosing may be trimmed with molding called stair cove. A handrail is usually required on any stairs with 4 or more risers. Balusters are the vertical pieces that support the handrail at each step. The newel post is a heavier vertical support used at the bottom of the handrail. The balusters, newel post, and handrail together are called balustrade. The trim parts and balustrade are shown in the second figure. Types of stairs. Stairs can be built with open stringers or housed stringers. Open stringers are cut in a sawtooth pattern to form a surface for fastening the treads. Housed stringers are routed out, so the treads fit between them. Stairs are also called open or closed depending on whether the space between the treads is enclosed with risers. Both the kind of stringers and the risers are shown on a section through the stairs. If the stringers are housed, the top of the far stringer shows on the section view. Stairs are also named according to their layout, as seen in a plan view. As you see in this picture. Straight stairs are the simplest design. They may or may not include a landing. L-shaped and U-shaped stairs are used where space does not permit a straight run. L-shaped and U-shaped stairs have a landing at the change in directions. The carriages for L-shaped and U-shaped stairs include vertical supports under the landing. Spiral stairs require the least floor space. They are made up of winder treads, usually supported by a center column. Temporary stairs used only during construction are usually of cruder construction. They are often made of 2x10 stringers with wooden cleats to support the treads. Service stairs in unoccupied spaces, such as a cellar, are often made of 2x12 open stringers with 2x10 treads. Stairs for exterior decks are also sometimes built with 2x12 open stringers. However, the carpenter should remember that these stairs are important to the overall appearance of the deck. Calculating risers and treads. Nearly all stair details include a notation showing the number of treads, with their width, and the number of risers, with their height, as shown in this figure. Occasionally only the total run, total rise, number of treads, and number of risers are given on the drawings, as shown in this figure. Notice that there is one more riser than there are treads. The builder must calculate the size of the treads and risers. The steepness of the stairs depends on the relationship between tread width and riser height. If the treads are wide and risers low, the stairs are gradual. If the treads are narrow and the risers high, the stairs are steep. To climb stairs with wide treads and high risers requires an uncomfortably long stride. To climb stairs with narrow treads and low risers requires an uncomfortably short stride. Building codes specify the maximum height of risers and depth of treads. Section R311.7.5.1 and R311.7.5.2 of the International Building Code specifies that risers cannot be more than 7 3/4 inches high and treads must be at least 10 inches deep. Although lower risers and deeper treads are allowed by the code, very low risers combined with very deep treads can make for awkward stairs. Stairs are designed by architects to comply with these rules and to be comfortable to climb and descend. To build the stairs as shown in this figure within these rules, the risers must be 7.5 inches high and the treads must be 10 inches wide. The height of the risers can be found by dividing the total rise by the number of risers. In this case 3 feet and 1/2 inch or 37.5 inches divided by 5 equal to 7.5 inches. The width of the treads is found by dividing the total run by the number of treads. In this case 3 feet 4 inches or 400 divided by 4 equal to 10. To calculate the size of the treads and risers in stairs with landings, treat each part as a separate stair. However, the treads and risers should be the same size in each part. Insulation and room finishing. After completing this unit, you will be able to perform the following tasks. Identify the insulation to be used in walls, floors, and ceilings. Identify the wall, ceiling, and floor covering material to be used. List all the kinds of interior molding to be used. Insulation. Thermal insulation is any material that is used to resist the flow of heat. In very warm climates, thermal insulation is used to resist the flow of heat from the outside to the inside. In cold climates, thermal insulation is used to resist the flow of heat from the inside to the outside. Insulating material is rated according to its ability to resist the flow of heat. The measure of this resistance is the R value of the material. The higher the R value, the better the material insulates. Typical R values for sidewall or attic insulation range from R13 to R38. Thermal insulation is generally available in 4 forms. Foamed in-place materials are synthetic compounds that are sprayed onto a surface and that then produce an insulating foam by a chemical reaction. Rigid boards are plastic foams that have been produced in board form at a factory. Another common type of rigid insulation is made of fiberglass that is manufactured in rigid form instead of as flexible blankets. Rigid boards are frequently used for foundation insulation, under concrete slabs, and for sheathing. Blanket insulation is in the form of flexible rolls or bats usually made of fiberglass wool. Loose pouring insulation can be any of a variety of materials that can be poured into place and has good insulating property. A common pouring insulation is loose fiberglass. The insulation is shown in the building sections. If the insulation is to be installed between studs, joists, or rafters, it will be sized accordingly. For example, if bats are to be used in a 2x4 wall, the insulation will be indicated as 3.5 inches thick, the width of a 2x4. One of the main reasons many houses are framed with 2x6 is to increase the space for insulation between the studs. Where insulation is used in ventilated spaces, there should be room for the necessary air circulation. Where the insulation includes a vapor barrier, such as craft paper, foil, or polyethylene, the vapor barrier is installed on the heated side of the wall. This prevents the moisture in the warm air from passing through the wall and condensing on the cold side of the wall. Such condensation can reduce the R value of the insulation and cause painted surfaces to blister and peel. Wall and ceiling covering. By far the most widely used wall surface material is gypsum wallboard. The most common thicknesses are 38-inch, 12-inch, and 58-inch. If gypsum board, sometimes called sheetrock, is to be used over framing that is spaced more than 16 inches OC or over masonry, the designer may call for furring. Furring consists of narrow strips of wood, usually spaced at 16 or 12 inches OC, to which the wall covering is fastened. The furring, if any, is to be used, and the thickness of the gypsum wallboard are indicated on the wall sections. Ceramic tile also is frequently used on bathroom walls. Ceramic tile may be installed over a base of cement board or special tile backer board. Gypsum wallboard is the most common ceiling treatment in new home construction. Suspended ceilings are common in commercial construction. Suspended ceilings consist of panels or ceiling tiles supported in a lightweight metal framework. The metal framework is suspended several inches below the ceiling framing on steel wires. Building sections or wall sections usually include a typical wall and ceiling. This is representative of what is planned for most of the walls and ceilings in the house. However, there may be some exceptions, such as the bathrooms or kitchen, where mold and water-resistant wallboard is required. Somewhere within the contract documents, you should find a complete list of all room finishes. This may be on one of the drawings, or it may be written into the specifications. This figure shows a room finish schedule that might be included on the drawings. It is common for the finish color to be left for the owner to choose. Finished floors. A list of possible floor materials would be very long. However, most of the materials fall into one of the following categories: wood, carpet, ceramic, masonry, and resilient materials such as vinyl tile. The finished floor covering is easily found in a schedule of room finishes, but the underlayment for each category is different. Underlayment is any material that is used to prepare the subfloor to receive the finished floor. Architectural drafters differ in how they indicate what underlayment is to be used and how the finished floor is to be installed. Some do not include any underlayment on the drawings, but rely on the builder's knowledge of good construction practices. This is a dangerous practice. If you find this situation, the architect should be asked for clarification. Sometimes when the drawings do not describe the underlayment, the specifications do. Some drafters indicate the underlayment on the floor plans. Other drafters include the details and section of each area with different types of finished floors, so the underlayment can be shown there. Interior molding. Molding is used to decorate surfaces, protect the edges and corners of surfaces, and conceal joints or seams between surfaces. Molding may be made of wood, plastic, or metal and is available in many shapes and styles. The shapes of commonly used wood molding have been standardized. Each shape is identified by a number. Most interior molding is shown in detailed drawings. The following are some of the most common uses for interior molding: window casing, window stool, door casing, base, bottom of wall, cove, top of wall, chair rail, middle of wall, trim around the fireplace mantel, trim around built-in cabinets. Cabinets. After completing this unit, you will be able to perform the following tasks. List the sizes and types of cabinets shown on a set of drawings. Identify cabinet types and dimensions in manufacturer literature. Showing cabinets on drawings. The layout of the cabinets can be determined by reading the floor plan and cabinet elevations together. The floor plan normally includes reference marks indicating each cabinet elevation. The floor plan shows the location of major appliances and may include some overall layout dimensions. When the building has separate electrical drawings, the electrical installer must coordinate these designated outlet locations between the electrical and architectural drawings. There may be electrical outlets shown on the architectural drawings and not shown on the electrical drawings. These variances must be resolved early in the rough-in stage of construction. More complete cabinet information is usually shown on the cabinet elevations. Cabinet elevations are drawn for each direction from which cabinets can be viewed. These elevations show the types of cabinets, their sizes, and their arrangement. Cabinet types and sizes are recognized by a combination of drawing representations and commonly used letter/number designations. Some drawings rely heavily on standard dimensioning and pictorial representation. This is true of the case shown in this figure. Other drawings include a letter/number designation for each cabinet, as shown in this figure. The letter part of the designation represents the type of cabinet. Architects and drafters vary in how they use letter designations, but they are usually easy to understand after a moment's study. Some typical letter designations are shown in this figure. The numbers in the cabinet designation represent the dimensions of the cabinet. Base cabinets are a standard height, usually 34.5 inches, resulting in 36 inches when a 1.5 inch countertop is added, and a standard front-to-back depth, usually 24 inches. Therefore, base cabinet designations only include 2 digits to represent width in inches. Wall cabinets are a standard front-to-back depth, usually 12 inches, but the width and height vary. Therefore, wall cabinet designations include 4 digits, 2 for width and 2 for height. The first and second digits usually indicate width, and the third and fourth digits usually indicate height. This figure explains a typical cabinet designation. In addition to cabinets, most cabinet manufacturers provide a variety of accessories. Shelves are finished to match the cabinets, so they can be used in open areas. Valances are pre-finished decorative pieces to use between wall cabinets, over a sink, for example. Filler pieces are pre-finished boards used to enclose narrow spaces between cabinets. A variety of molding may be used for trim. Lake house specifications. Lake house specifications. After completing this unit, you will be able to perform the following tasks. Find specific information in construction specifications. Apply information from specifications to specific construction drawings. Introduction. Construction drawings provide much information about how a building is to be constructed, the positions and sizes of the parts and materials to be used. Some information is more practically recorded in written form, and the construction specifications, often referred to as the specs, provide that information. For example, it is not practical to show the grade of lumber to be used for roof framing or to indicate who is responsible for cleanup after construction is finished. For single-family homes, all of the necessary technical information is often conveyed on the drawings. In this case, there are likely to be extra notes on the drawings to convey the information that would otherwise be conveyed in separate specifications. The drawings for the Hidden Valley Townhouse in Section 3 are a good example of notes on drawings that provide technical specifications. In this unit, we consider specifications that are written separately from the drawings. CSI format. Large and complex buildings can require a lot of information to be conveyed in the specs. Specs for a large commercial construction project can be hundreds of pages. To make it easier to find information, specification writers follow the Construction Specifications Institute's Master Format, CSI format, for organizing their specs. Master Format standardizes titles and section numbers for organizing data about construction requirements, products, and activities. It can include up to 48 divisions with numbered sections in each division. While this format makes organization of large projects easier to follow, it would be very cumbersome for a small project, like a single-family home. A more practical and often used system is to partially follow the CSI format. The major divisions follow the CSI format. The numbering of subsections is modified or dropped altogether. The format of the specs for the lake house is an adaptation of CSI format. The major divisions follow CSI numbering, with unused divisions omitted. The subsections have been rearranged to better fit the needs of the project. Each of the technical divisions begins with a brief description of the work covered by that division. Also included are a description of materials needed for that work and subsections for each type of work in the applicable division. To find a particular part of the construction project in the specs, use the following steps. Look up the appropriate division on the table of contents. Read the work included at the beginning of the division to be sure you have the right division. Find the description of the necessary materials right after the work included. Read the applicable subsection covering the work you want to do. Here are the specifications for lake house contents. General conditions. The general conditions of the contract for construction. AIA Document A107, whether or not bound herein, are hereby incorporated into, and made a part of this contract and these specifications. General requirements. Temporary conveniences. The general contractor shall provide suitable temporary conveniences for the use of all workers on this job. Facilities shall be within a weathertight, painted enclosure complying with legal requirements. The general contractor shall maintain all temporary toilet facilities in a sanitary condition. The general contractor shall keep the excavation and the basement free from water at all times and shall provide, maintain, and operate at his own expense such pumping equipment as shall be necessary. Protection. The general contractor shall protect all existing driveways, parking areas, sidewalks, curbs, and existing paved areas on or adjacent to the owner's property. Grade lines, levels, and surveys. The owner shall establish the lot lines. The general contractor shall establish and maintain benchmarks. Verify all grade lines, levels, and dimensions as shown on the drawings, and report any errors or inconsistencies before commencing work. Lay out the building accurately under the supervision of the architect. Final cleaning. In addition to the general room cleaning, the general contractor shall do the following special cleaning upon completion of the work. Wash and polish all glass and cabinets. Clean and polish all granite. Clean and polish all hardware. Remove all marks, stains, fingerprints, and other soil or dirt from walls, woodwork, and floors. Guarantees. The general contractor shall guarantee all work performed under the contract against faulty materials or workmanship. The guarantee shall be in writing with duplicate copies delivered to the owner. In case of work performed by subcontractors where guarantees are required, the general contractor shall secure written guarantees from these subcontractors. Copies of these guarantees shall be delivered to the owner upon completion of the work. Guarantees shall be signed by both the subcontractor and the general contractor. Foreman. The general contractor shall have a responsible foreman at the building site from the start to the completion of construction. The foreman shall be on duty during all working hours. Fire insurance. The owner shall effect and maintain builder's risk completed value on this job. Site work. Work included. This work shall include, but shall not be limited by the following: clearing the site, excavating, backfilling, grading, and related items, removal of excess earth, protection of existing trees to remain on the site. All excavation and backfilling required for heating, plumbing, and electrical work will be done by the respective contractors and are not included under site work. It is the contractor's responsibility to field inspect existing conditions to determine the scope of the work. Clearing. Clean the area within the limits of the building of all trees, shrubs, or other obstructions as necessary. Within the limits of grading work as shown on the drawings, remove such trees, shrubs, or other obstructions as are indicated on the drawings to be removed, without injury to trunks, interfering branches, and roots of trees to remain. Do cutting and trimming only as directed. Box and protect all trees and shrubs in the construction area to remain. Maintain boxing until finished grading is completed. Remove all debris from the site. Do not use it for fill. Excavation. Carefully remove all sod and soil throughout the area of the building and where finish grade levels are changed. Pile on site where directed. This soil is to be used later for finish grading. Do all excavation required for footings, piers, walls, trenches, areas, pits, and foundations. Remove all materials encountered in obtaining indicated lines and grades required. Beds for all foundations and footings must have solid, level, and undisturbed bed bottoms. No backfill will be allowed and all footings shall rest on unexcavated earth. The contractor shall notify the architect when the excavation is complete so that he may inspect all soil before the concrete is placed. Excavate to elevations and dimensions indicated, leaving sufficient space to permit erection concrete forms, walls, waterproofing, masonry, and inspection of foundations. Protect the bottom of the excavation from frost. Backfill. All outside walls shall be backfilled to within 6 inches of the finished grade with clean fill. Backfill shall be thoroughly compacted. Unless otherwise directed by the architect, no backfill shall be placed before the first floor framing is in place. No backfill shall be placed until all walls have developed such strength to resist thrust due to filling operations. Grading. Do all excavating, filling, and rough grading to bring the entire area outside of the building to levels shown on the drawings. Where existing trees are to remain. If the new grade is lower than the natural grade under the trees, a sloping mound shall be left under the base of the tree extending out as far as the branches. If the grade is higher, a well shall be constructed around the base of the tree to provide the roots with air and moisture. After rough grading has been completed and approved, spread topsoil evenly to the previously stripped area. Prepare the topsoil to receive grass seed by removing stone, debris, and unsuitable materials. Hand rake to remove water pockets and irregularities. Seeding will be done by the owner. Furnish and place run of bank gravel as approved under all floor slabs. Concrete. Work included. Provide all materials, labor, equipment, and services necessary to furnish, deliver, and install all work of this section, as shown on the drawings, as specified herein, and/or as required by job conditions including but not limited to the following. Concrete for all footings and piers. Concrete for all foundation walls. Concrete for all slabs on ground. Concrete for slab at heat sink. Furnishing and installation of all required anchors. Supplying fabrication and placement of all reinforcing bars and mesh and wire reinforcement for concrete where shown, called for, or required with proper supporting devices. Erection of all forms required for concrete work and removal upon completion of the work. The finishing of all concrete work as hereinafter specified. Porous fill below slabs on ground. Material. Fine aggregate. Fine aggregates for concrete shall consist of natural sand having clean, hard, sharp, uncoated grains free from injurious amounts of dust, lumps, soft or flaky particles, shale, alkali, organic matter, loam or other deleterious substances. Coarse aggregate, stone. Coarse aggregates shall consist of crushed stone or gravel having clean, hard, strong, durable, uncoated particles, free from injurious amounts of soft, friable, thin, elongated or laminated pieces, alkali, organic, or other deleterious matter. Water. All water used in connection with concrete work shall be clean and free from deleterious materials or shall be water used for drinking daily. Portland cement. Portland cement shall be an approved domestic brand complying with standard specifications for Portland cement, ASTM designation C150, Type 1. Only one brand of cement shall be used throughout the course of the work. All concrete is to be machine mixed in an approved mixer with a water metering device. Concrete is to reach a compressive strength of 2,500 psi after 28 days. Reinforcement. All reinforcing, unless otherwise shown or specified, shall conform to ASTM A615, grade 60. Wire mesh reinforcing shall have a minimum ultimate tensile strength of 70,000 psi, and shall conform to ASTM specifications A185, latest edition. Inspection and placing. All reinforcing shall be free of rust, scale, oil, or other coatings that tend to reduce the bond to concrete. All reinforcing is to be tied with 18-gauge wire at intersections, and shall be held securely in position during the pouring of concrete. The architect will inspect all footing beds, forms, and reinforcing, just prior to placing concrete for footings, foundation, and slabs. All concrete shall be placed upon clean surfaces and properly compacted fill, free from standing water. The concrete shall be compacted and worked into corners and around reinforcing. All concrete to be true and level as indicated on drawings, to within ± quarter inch in 10 feet. Finishing. Slabs in occupied spaces shall be troweled smooth and free of trowel marks. Slabs in unoccupied spaces will have wood float finish. Masonry. Work included. This work shall include but not be limited by the following: brickwork, concrete block work, mortar for brick and block work. Materials. Delivery and storage. All materials shall be delivered, stored, and handled so as to prevent the inclusion of foreign materials and the damage of the materials by water or breakage. Packaged materials shall be delivered and stored in the original packages until they are ready for use. Materials showing evidence of water or other damage shall be rejected. Brick shall be chosen by the owner from approved samples. Concrete block shall be load-bearing, hollow concrete masonry units and shall conform to the standard specifications of ASTM C145-71. Mortar used for laying brick and concrete block shall consist of 1 part masonry cement, 2 3 parts sand. The mortar ingredients shall comply with the following requirements: masonry cement, ASTM C91T Type 2. Aggregates, ASTM C144. Water, clean, fresh, free from acid, alkali, sewage, or organic material. Installation. All work shall be laid true to dimensions, plumb, square, and in bond and properly anchored. Joints shall be finished as follows. All brick shall be laid on full mortar bed with a shove joint. All joints shall be completely filled with mortar. All horizontal and vertical joints shall be raked 3/8 inch deep. All mortar joints for concrete block masonry shall have full mortar coverage on vertical and horizontal face shells. Vertical joints shall be shoved tight. Full mortar bedding shall have ruled joints. Concealed work shall have joints cut flush. Fill voids in top course with masonry and set anchor bolts as shown on construction drawings. Protection: cover the walls each night and when the work is discontinued due to weather. Cleaning and pointing. Point up all the voids and open joints with mortar. Remove all of the excess mortar and dirty spots from the entire surface. Upon completion, all brickwork shall be thoroughly cleaned with clean water and stiff fiber brushes and then rinsed with clean water. The use of acids or wire brushes is not permitted. Structural steel. Work included. This work shall include but not be limited by the following: structural tube columns, welded flanges and plates, structural steel rafters and beams, stanchions at railings. This contractor shall supply fabricated stanchions to be installed by others. Grouting base plates. Materials. All structural steel to conform to ASTM A36. Welding electrodes to conform to American Welding Society A5.1 E70 series. Fabrication and erection. Drilling or punching of holes in columns, beams, and rafters shall not be permitted unless approved. Welds shall be by qualified operators and shall achieve complete penetration without voids, cracks, or porosity. Concealed structural steel shall have 1 coat of approved rust-resistant primer. Wood and plastics. Work included. All lumber, plywood, rough hardware, trim, paneling, and finish carpentry joinery and millwork required or implied by drawings and/or specifications. Cabinets and countertops are not included in this section. Material. Grade or trademark is required on each piece of lumber. Only official marks of association under whose rules it is graded will be accepted. Plywood shall conform to standards. Product standards PS 66 and shall be branded or stamped with type and grade. Moisture content shall not exceed 19% for framing lumber, 12% for plywood, and 8% for finish millwork. Work that is to be finished or painted shall be free from defects or blemishes on surfaces exposed to view that will show after the finish coat of paint or stain is applied. Defective materials not up to specifications for quality and grade for its intended use, or otherwise not in proper condition, shall be rejected. Rough lumber shall be dressed 4 sides, air-dried, well-seasoned, sound, and free from splits, cracks, shakes, and wanes, loose or unsound knots, and decay and excessive warp. Species and grades shall be those listed. Douglas fir or hemfir for rough carpentry. Each piece marked as to grade and free from defect. Treated lumber, southern yellow pine, ACQD treated per AWPA standards. Finish lumber and millwork, clear white pine or ponderosa pine. All nails, spikes, screws, bolts, joist hangers, and timber connectors as indicated, noted, or detailed on drawings, and as required to produce a safe, substantial, and workmanlike job in all respects. Rough carpentry. Install all rough wood framing, nailers, edge members, curbs, blocking, grounds, rough sills, backing, furring, and the like as indicated, detailed, noted, or required to properly support, back up, and complete the work of this section and of any or all trades under these contracts. Securely attach and anchor to adjacent construction as detailed or as approved if detail is not provided. Shim to line if so required to provide a uniform base for any other work. Provide double studs adjacent to and headers of size indicated over all openings. TJI joists and rafters to be installed according to manufacturer's instructions. Finish carpentry. Provide all rabbets, splines, plows, and other cuts as detailed or required for neat, solid fitting and joining. Finish millwork where indicated to have a clear finish shall be dressed and sanded, free from machine and tool marks, abrasions, raised grain, and other defects on surfaces exposed to view. Construction and workmanship of millwork items shall conform to or exceed the requirements of AWI and good shop practices. Joints shall be tight and sop-formed as to conceal shrinkage. Interior millwork, running finish, and trim shall be in as long lengths as practicable, shall be spliced only where necessary, and only when approved by the owner. All such splices shall be beveled and jointed where solid fastenings can be made. Thermal and moisture protection. Work included. Damp-proofing basement walls. Vapor barriers. Thermal insulation. Roofing. Flashing. Caulking and sealants. Materials. Damp-proofing on basement walls to be Sonneborn Building Products, semi-mastic hydrocide 600 or approved equal. Vapor barriers under concrete slabs to be 4 mil thick polyethylene. Vapor barriers on insulated walls and roofs to be 4 mil thick polyethylene. Insulation exposed to earth shall be Dow Styrofoam SM, or 5.4 per inch. All rigid board insulation not exposed to earth shall be Owens Corning, high-R sheathing, or 7.2 per inch. Batt insulation shall be Owens Corning Eco Touch fiberglass unfaced, or approved equal. 3/2 inches thickness are 11. 6 inches thickness are 19. 9 inches thickness are 30. Metal flashing 28 gauge aluminum. Caulking to be acrylic polymer conforming to FFTTS 00230. Damp proofing. Apply 2 coats of asphalt damp proofing over all concrete or masonry wall surfaces to receive earth backfill. Apply polyethylene vapor barrier over gravel fill at all concrete slabs. Vapor barrier sheets to be lapped 6 inches minimum. Apply polyethylene vapor barrier to the heated side of all insulated frame walls and roofs. Thermal insulation. Pack all voids and cavities in exterior walls and roof. Avoid compressing batt insulation. Cut and fit insulation and vapor barriers as necessary for snug fit. Allow minimum air space of 1/2 inch between insulation and roof sheathing. Rigid insulation is to be nailed and glued with down mastic number 11, according to the manufacturer's instructions. Roofing. Roofing to be installed according to manufacturer's instructions. Doors and windows. All doors, door frames, windows, skylights, trim for each, and all hardware not included elsewhere. Finishes. Work included: gypsum wallboard, ceramic tile in baths and toilet rooms, quarry tile floors, painting and varnishing.